Okay, differentiation, and another of my favorite parts of differentiation, the product rule. Hit pause, copy the lesson objective down. When you're ready, hit play again, and we'll go on to define the product rule. And so, the product rule. Well, we can say that if y is a product of two functions, let's write this down here. If y is a product of two functions, it's a dodgy 2 there, and let's define the functions of u of x and v of x, then we can write y is equal to u times v. And when we were to differentiate that, dy over dx, differential would be given in terms of u and v. It would be u times the differential of v, dv over dx, plus v times the differential of u. And that is the product rule, which we're going to take forward. Now, before you make notes on that, I'm just going to change the pen color. We can also write it in a slightly different form. Okay, so if we say that y is a product of two functions, f of x and g of x, we can say that the differential dy over dx is equal to f of x times the differential of g dash of x, plus g of x times the differential of f of x. So you could see it in either form. Okay, you need to know this. It's not given to you in the exam. It's not given to you in your booklet. Okay, now by far the most useful form is this one. Okay, we use this one quite a lot, but some of you might want to use this, but either way. Right, hit pause, make some notes. When you're ready, hit play again. I'm going to look at an example. Okay, so we've got to differentiate this function here. F of x, we're told, is equal to x squared times the square root of 3x minus 1. We've got to differentiate it. I'm going to call it y, same thing, is equal to x squared, and instead of square roots, I'm going to put this 3x minus 1 to the power of a half. Much better for differentiating. So let u equal x squared and v be equal to 3x minus 1 to the power of a half. Now I'm going to differentiate with respect to x, so du over dx is equal to 2x, and here dv over dx, slightly more complicated, because when I look at this function 3x minus 1 to the power of a half, I need to use the chain rule. Now I can use the chain rule. Instead of calling 3x minus 1 u, because we've used u, I can call it t. Or I can do it quite quickly here. To do that, I differentiate what's in the brackets, 3x minus 1, differentiate that gives me 3. And then I differentiate with respect to the brackets. So imagine that was a function t to the power of a half. That would give me, I'll multiply it by a half, so times a half, got my brackets, 3x minus 1, and subtract 1 to the power of minus a half. Simplify that, that's 3 over 2 times 3x minus 1 to the power of minus a half. Okay, you can check it using the chain rule, which you're expert at after the last lesson. Now, differentiating the product, dy over dx, is equal to u times dv over dx plus v times du over dx. So all we need to do now is substitute. U is equal to x squared, and dv over dx is 3 over 2. So times, the dot is times 3 over 2 times 3x minus 1 to the power of minus a half, plus v, that's 3x minus 1 to the power of a half, times dv over dx times 2x. Simplify, that's equal to 3x squared over 2 times 3x minus 1 to the power of minus a half plus 2x times 3x minus 1 to the power of a half. Now, to the power of a half means reciprocal, 1 over, so we could write 3x squared all over 2 times 3x minus 1 to the power of a half plus 2x times 3x minus 1 to the power of a half. Okay, so that's dy over dx. However, I can simplify this function here. So I'm going to attempt to do that in this space here. Let me just change the color of my pen. Let's go blue. Right. So to simplify, let's write the function that we've got. Not much space here, so I've got to be careful. dy over dx is equal to 3x squared all over 2 times 3x minus 1 to the power of a half plus 2x times 3x minus 1 to the power of a half. Okay, now in order to simplify it, I have to have the same denominator. So I can multiply this side by 2 brackets 3x minus 1 to the power of a half, numerator and denominator. So let's do that. Let's see, something different. Let's go black. So it's going to be times 2 brackets 3x minus 1 to the power of a half over 2 times 3x to the power minus 1 to the power of a half. Let's go back to blue. And so we have 3x squared plus 2x times 2, so 4x brackets 3x minus 1 to the power of a half times 3x minus 1 to the power of a half. It's just 3x. You add the indices, so it's the power of 1 all over the same denominator, 2 brackets 3x minus 1 to the power of a half. Nearly there. So that's 3x squared and simplify, plus 12x squared minus 4x all over 2 brackets 3x minus 1 to the power of a half. And so 3x squared and 12x squared gives us 15x squared minus 4x all over 2 brackets 3x minus 1 to the power of a half. Okay, good. So copy that down, and when you're ready, hit play again, and we'll move on to look at another example. Okay, let's have a look at this example we've got here. What have we got? We've got y is equal to e to the power of 4x sine squared 3x, and then we've got to show that when we differentiate it, it becomes this function here. And we've got to determine what a and b are. So we're given y is equal to e to the power of 4x sine squared 3x. So let's split the function up, u and v. Let u be equal to e to the power of 4x and v be equal to sine squared 3x. So differentiating u with respect to x, du over dx is equal to 4e to the power of 4x. Differentiating v, a little bit more complex, dv over dx. That's going to be equal to, well, again, just chain rule. So you could say let t be equal to sine 3x and go down that route. Or we could differentiate it as it is. So if we have, instead of sine squared 3x, if we just imagine that that's in the chain rule u squared, differentiating that gives us 2u or 2 sine 3x, and then we differentiate sine 3x itself, gives us 3 cos 3x. Simplify that, gives us 6 sine 3x cos 3x. So make sure you check that out using the chain rule. Now, product rule, dy over dx is equal to u times dv over dx plus v times du over dx, and we simply substitute now. U is e to the power of 4x times dv over dx, which is times 6 sine 3x cos 3x plus v, which is sine squared 3x, times du over dx, 4e to the power of 4x, times 4e to the power of 4x. So, simplifying, if I look at, this is the function that I need to get. So if I simplify, I can, I tell you what, in the first instance, before I do that, let me just write this out. 6 e to the power of 4x sine 3x cos 3x plus 4e to the power of 4x sine squared 3x. That makes it easier actually to see how I can factorize in order to get this term. So e to the power of 4x sine 3x is outside. So if I factorize that, taking e to the power of 4x sine of 3x out, it leaves me with 6 cos 3x plus 4 sine 3x, which is exactly the form that the question wanted me to put that differential in. This implies then that a is going to be equal to 6 and b is going to be equal to 4. Okay, so before you hit pause, I tell you what we'll do. We'll have a look at that chain rule of v, just in case you're unsure. So let's use a blue pen. It's just a little aside. Okay, so we said that v is equal to sine squared 3x. So let t be equal to sine 3x. Okay, so that means v is equal to t squared and t is equal to sine 3x. Differentiating v with respect to t is equal to 2t. Differentiating t with respect to x is 3 cos 3x. And so by chain rule, this is v wants to differentiate with respect to x, dv over dx is equal to dv over dt times dt over dx. And when we put that together, dv over dt is 2t times dt over dx, 3 cos 3x, which is equal to, remember t is equal to sine 3x, so 2 times 3 is 6 sine 3x cos 3x. Okay, that's just the regular way of doing the chain rule, or you could do it quickly here. As you get more proficient, you'll do it quickly. Okay, so hopefully you won't need this blue section. If you do, copy it down. If not, just copy the example down. hit pause, and I've got some questions for you. Okay, so again, a new concept, product rule, so it's going to need some practice. So I would say questions 1 and 2 are important, doing all of them. Okay, and then practice all the way through. Good luck.